For target 9A, there's quite a bit to this problem. So there's basically 5 things that we have to do. So 1, 2, 3, 4, and 5. And so I'll explain it. So basically up and down is whether our A or whatever is right next to the x squared, if it's positive, it's up. If it's negative, it's down. So I'll put a U and a D. And then basically it goes hand in hand. If it's up, it's a minimum. And what it means by up is if the graph is opening upwards. So if we have a parabola, it'll look like this if it opens upwards versus a different one if it opens downwards. So the reason why there's a minimum is if it's opening upwards, like in this first one, the lowest it'll go is a minimum, so the point that I've kind of bolded there. As for the second one, since it's opening downwards, so the mouth is like opening down, it'll only ever reach this top point before going to back down. It's kind of like a roller coaster, so this is a maximum height. So min, and this one's max. Now for our line of symmetry, the line of symmetry is just basically if you take the parabola and you were to chop it in half, it's symmetrical, meaning this side over here on the left looks identical other than being somewhat flipped to this other side. So our line of symmetry is this line, the dotted line here, that cuts that parabola in half. And so to kind of define what this A and this B is, you got to look at what standard form looks like. So A x squared plus B x plus C. This is standard form. It's just like the mathematical way to represent like a typical equation. So our A is whatever is in front of that x squared. So in this case, that's A. This would be our B. And this would be our C. And so how you do your line of symmetry is you define your A, your B, and your C based off of what you're seeing in your equation. So like for this one, my A, since there's nothing in front of that x, I only have one of them. So there's one x squared. For my B, I have 2. And for my C, since it's negative, it's a negative 3. And we don't really have to even worry about this C term, it's just kind of extra for you. And so the line of symmetry, if we were to set this equation up, we would put the B here and the A there. So it would be negative 2 divided by 2 times A. So 2 times 1 is negative 2 divided by 2, which is a negative 1. So that's how you figure out your line of symmetry. And if we were to fill in the up and down, so since our A, we know a little bit more about our A. If our A is positive or negative, in this case it's positive, it's opening up. And since it's opening upwards, like in this first example, it's a minimum. For our vertex, kind of the cool thing is that our line of symmetry is the x value. And then we have to figure out what our y is by plugging it, whatever our line of symmetry is, back into the equation, wherever we see an x. So in our example, for 1, our line of symmetry we figured out was this negative 1 here in the red. And so I'll put that there. So negative 1. And then I'm going to put all of my equation down here. So x squared plus 2x minus 3. And now I'll fill in everything that has an x with a negative 1. So this x squared gets a negative 1. This 2x gets a negative 1 in place. And since that negative 3 doesn't have anything, it doesn't get a negative 1. And so negative 1 squared, or negative 1 times negative 1, is a positive 1. Negative 1 times 2 is a negative 2. And then the negative 3 just is brought down. So I like to add my negatives first, so negative 2 and my negative 3 gets added to a negative 5. And so 1 minus 5 is a negative 4. So this negative 4, which I'll box in blue, goes here. And so it's important to see that we use our line of symmetry to first provide our x value, and then we use it to find our y. And so now we can fill in our t-table. So we always put our vertex dead center in the t-table, so negative 1 and negative 4. And then I pick one point that's greater than negative 1. So 1 point larger would be 0, and 1 point more negative than negative 1 would be negative 2. Then I do it again, so I need 1 point that's more positive than 0, so 1, and 1 point that's more negative than negative 2, which is negative 3. And what's nice is this top half mirrors our bottom half in terms of our x values, or our y values. So whatever our 0 gives us for our y, our negative 2 will give us the same value. And I'll show that to you. So we use these x values to plug into our original equation. So that x squared, this equation here, I'll just keep plugging these x values in to wherever I see an x. So I'll put a 0 in for x squared plus 2 times 0 minus 3. So this is 0 and this is 0. So all we're left with is negative 3. So for our x value, when we have 0, it gives us a y value of negative 3. So since they're mirrors, this one is also negative 3. And I'll show that. So if I put it in negative 2 into the same equation, things will start to cancel out because of the negative. So negative 2 squared is negative 2 times negative 2, which is a positive 4. And negative 2 times 2 is a negative 4. So 4 minus 4 is 0. And then our negative 3 gets dropped down. So that also, 0 minus 3 still leaves us with negative 3. So we get the exact same values. And so now all we have to do is figure out what this 1 is, because that will tell us what our negative 3 is. And so 1, I'll just do the equation here. 1 squared plus 2 times 1 minus 3. So 1 times 1 is 1, plus 2 times 1 is 2, minus 3. So we get basically 3 minus 3 gives us 0. So that one's 0, which makes our negative 3 0. And the last thing for this equation, or this problem, is to plot our points. So I'll do our negative 1, negative 4 first. So I do my x values, and then my y. So I go to -1, -4. I'm going to remove this little arrow. It looks like a negative. And so then I go to 0, which I don't move, and then I go down to -3. And then I'll plot my 1, 0, so I go right to 1, and I don't go anywhere for the y value, so I put a point there. And so you'll start to see one arm of our parabola. And so I'll label our line of symmetry in red because that's what our x value is in our vertex here. So our line of symmetry is at -1. And we'll start to see that another arm will appear from the other side, the left side of the line of symmetry. So I'll plot my -2. So I go right to -2, down to -3, and I'll plot my point there. And for my next one, I'll do -3, 0. So I'll go to -3, and I don't go anywhere for my y. And then I'll attach my next arm. So my graph is complete. The last thing I have to do is this x-intercepts. And so what that means is wherever our parabola crosses the x-axis, so this axis in yellow, that is considered a solution or an x-intercept. So if you notice, it crosses here at -3, and it crosses at +1. So -3, +1 are our x-intercepts. Target B is a little bit easier because our graph is already graphed for us. So all we need to do is figure out where our x-intercepts are. So kind of the last part of that last problem was determining where it crossed this x-axis. So I see that it crosses at 1, and this one looks like it crosses at -5. And then this last set of problem, you're just basically doing all that criteria all over again. So first, min or max, up or down, line of symmetry, which is x equals -b over 2a, your vertex, and a t-table. And then you'll have to tell us what the x-intercepts are, so where it crosses that x-axis here.